Welcome to the DSL Systems tutorial on fault finding plant items. This is the first one which covers motor driven items such as conveyors, elevators, mixers, fans and so on. Other items such as slides, gates, doors, diverters, rotary spouts, probes, explosion monitors, etc. will be covered in another tutorial, as will specialised items such as grinders and pellet mills. On the right hand side here I've got a simplified mimic of a number of items, conveyors, elevator and some bins. And what I'll do is I'll initially start up a route. So you'll see the items go from orange to green as they're running. So material now would be coming in the bottom of this elevator, up the elevator, across BC19, down this diverter, along conveyor BC21, along BC22, through the slide then into the bin. So when you have a problem with an item, with a motor, the colour graphics will normally show the item in red, but colourblind people will have a different colour. So if I simulate a problem now, so what I've done is I've simulated this overflow flap, this blockage flap at the end of conveyor BC1 is come up. So the conveyor is in alarm, so it shows red, and to stop more material going onto that conveyor, the system has stopped BC19 and BE4. So the first thing you should do is to look at the alarm in the alarms window, and the text will help you decide what the problem is. In this particular case, BC21 blending conveyor overflow flap. So that's pretty self-explanatory. Now there can be different alarm windows depending on the areas. And alarm area 1 is normally used for intake area alarms, alarm area 2 for weighing, batching, mixing, alarm area 3 for pellet press control areas and so on. And you can have up to 9 different types of alarms depending on the signals which come into the PLC for this item. So going back to this alarm now, if I fix this problem, I go up and what I do is I unblock the end of this conveyor, and you'll see that the overflow flap is now not up. Nothing will happen though until I accept the alarm. So I go onto the alarm, click the button and do an alarm accept. So now the system will retry, the conveyor starts, and then the upstream items automatically restart. So of the 9 possible alarms you can have, fail to start. Fail to start means that the output to start the item was set, but no running signal was received within a certain time. Depending on how it's wired up, it could mean that the item is isolated, the emergency stop is pressed, it's tripped on overload, it's blocked, there's a wiring problem, or a number of other faults. The first thing you should do is to go and have a look at the actual item and see if there are any physical problems. Once you get a fault on a motor-driven item, the output from the PLC will usually have been removed, as I've just shown you, and so the item will only restart once you accept the alarm on the graphics. Failed running means that the item was running, but the running signal disappeared from the PLC, and this could be a number of faults similar to the ones I've described previously. Not stopped is self-explanatory. The control system wanted to stop the item, removed the output from the PLC, but the running signal remained on, and usually a fault like this will be electrical. There are other alarms depending on the signals that you have: fault if on, fault if off, isolator circuit fault, contactor fault and slipping. These are when you have additional signals into the PLC which help with fault diagnosis. And these may also include block-up flaps, safety doors open, emergency stop buttons and so on. Contactor fault is a problem in the electrical panel. Perhaps the thermal overload is stripped. Sometimes thermal overloads will automatically reset themselves after a time. Sometimes there's a button on the outside of the panel, and sometimes you have to go into the panel to reset the overload. Your site operating procedures will cover these aspects. Once the thermal overload has been reset, you have to manually accept the alarm on the graphics for the item to restart. Slipping. This is normally for elevators only, and it indicates that the elevator belt is slipping and needs adjustment. High current. If the DSL AutoPilot4Feed system is monitoring current for the item and the reading goes over a certain amount, then feed into the item is stopped until the item recovers. And I can show that by setting current high. So what I've done now is I've set the current for BC21 high, and the alarm will tell you what's happened. BC21 blending conveyor high current. The conveyor continues to run, but the items feeding material onto that conveyor have been stopped. If I put the value back again, then the alarm automatically goes and the items that feed material onto BC21 automatically restart. There are 10 possible input signals into the PLC for an item. And if you've got access to item configuration, you can see what's been configured for an item. So you go to Menu, Configure, Items, and then enter the ident of the item that you're interested in. And there's a number of tabs along here. The first one, Inputs, shows all the inputs that are relevant for this item. Now first of all, I've got to explain there are two special values here, 10,001 and 10,002. 10,001 is an internal flag, we call them, which means that it's always true, so it's always on, and 10,002, which is always off, always false. So any number between 1 and 10,000 is a real electrical signal wired into the PLC, and any value greater than 10,000 is an internal flag. And sometimes these are generated by logic within the computer, for example, by comparing some values to do something. You can use your cursor to hover over a value to see what the signal description is. So if I go over this one here, you'll see this is the inspection door, and this one here is the trip signal. On the Alarms tab, you can see all the configured alarms for this item. The alarm area 5 shows which alarms window the alarms will appear in, as I described before. And you can use the cursor to hover over an alarm number to see what the text will be. For instance, this one here, blending conveyor tripped. While you're here, you can click on the Timers tab to see how long an item is allowed to take to start. So here's the start timer. If you click on the value here and press F2, it gives you the value here in seconds, 5 seconds. So that means that when the output is set, the system allows 5 seconds before the running signal comes back, otherwise it's declared as failed to start. 5 seconds would be typical for most items, but if a mixer has a star-delta contactor arrangement, it will take longer than 5 seconds. So when you have an item fault, you've got to decide what to do. Go to the actual item to have a look to see if you can see a problem. Go to the electrical panel to see if there's a problem in there. Retry the alarm by going on the graphics and accept alarm, or call for help. Could be electrical, mechanical, or some other problem. There is a very useful facility on the system to see the history of any item. If you go to Menu, View, Audits, this will show everything that's happened with every alarm and every audit on the system. Now it defaults to the last hour from here to here, but this log actually goes back for years, so you can have a look at any time period. So for the last hour, if I click on the magnifying glass here, it shows all of the alarms and audits that have happened in the last hour. Now if I'm looking for a particular one, I can enter here PC21, it's not case sensitive, press on the button here again, and this only shows you alarms to do with PC21. So you'll see this is the time, the latest one. So go back in time, you can see the overflow flap was cleared at 1558. High current was set 1526. Overflow flap here was set at 1522, and so on. I trust this tutorial has helped you with motor-driven plant items. Thank you for watching.